This is the second lesson looking at the parts of the CPU. These are the keywords that we looked at last lesson. You should be able to explain each of these in detail using the appropriate language. If you can't, you need to go back and look at your notes. We're still looking at the first objective on our PRC, 1.1.1, structure and function of the processor. This is a summary of what we did last lesson. Now, the control unit decodes instructions. It's very important that we get instructions and data correct. It's not decoding data, it's decoding instructions. It sends control signals to coordinate the movement of data, but it also executes instructions. It can't execute data because data is just something that's saved. It might be a number, whereas an instruction might be to save, or it might be to add, or a mathematical equation. It also controls the buses. The buses, remember, the three buses are known as the systems bus. The first bus is the control bus. This is bidirectional and it transmits control signals from the CU to the other parts of the processor. It also might be transmitting signals to the I/O devices or the memory. The data bus carries data. It carries data from one place to another. It doesn't carry instructions. The address bus carries the location, so the location of the address where the data is going to be moved from or to. ALU stands for the arithmetic logic unit and it can be found inside the CPU. It performs arithmetic and logical operations on data. That might be add, subtract, multiply, divide on numbers. These can be fixed or floating point. A fixed number is a whole number. A floating point number is a number such as 7.2 with a decimal place. It can also perform shift operations or Boolean operations. A shift operation happens on binary. You've probably seen this from GCSE Computer Science where we multiply or divide binary. These are called binary shifts. It can also carry out Boolean operations. That might be and, or, not, etc. There are others, XOR, exclusive or, there's lots of other operations that it can do. Now there's lots of different ways that you can store data on a computer and we're going to be looking at memory and storage in a future lesson. But a register is a tiny memory cell. It's not big, it's only got space for a very small amount of data and they operate at extremely high speeds. That's because they're inside the CPU. There's no moving of data or information to RAM or to external storage or a hard drive. It's right there in, as we say, the CPU, the brain of the computer. This is where all our shift operations or our logical or arithmetic operations take place. Generally, there are 16 general purpose registers in the CPU. Modern computers, though, as I've put on this slide, have many registers. Some use a single accumulator to keep it simple, and it can take the place of general purpose registers. But for this, we're assuming that all calculations take place in a single register called the accumulator. Now remember, there are lots of different registers. These are tiny blocks of memory inside the CPU. There are other registers other than the accumulator, and one of those is the PC, the program counter. Now this program counter holds the address of the next instruction to be executed. It might be doing something at the moment, but it needs to know where the next address is. Okay, so for example, it might be adding something at the moment, and it needs to know what it needs to do with that value that it's just added, and that might be storing it in memory. So it's holding the address of the next instruction. It doesn't know what that instruction is, but it knows where to go to get that instruction. It might be an instruction in a sequence. It might be a branch, so it might have some an address to jump to. It might be copied from this current instruction register to the PC as well. We've got 3 more different registers that you need to learn about. The CIR, the Current Instruction Register. This holds the current instruction being executed, the actual instruction. It's divided into 2 parts, the opcode and the operand, and we're going to explore those more in a future lesson. The MAR, the Memory Address Register. This holds the address of the memory location where the data or instructions is to be fetched from. That might be in RAM. So it holds the address, it's not holding data. The Memory Data Register. This is at the MDR. This is a temporary store of data. So it's temporary. Data is only going to be stored there temporarily while something is being read or written to memory. Now you might be a bit confused by some of these because you've not actually seen them in action, and that's because part of the specification says that you have to be able to use these in assembly language, and that's what we're going to be looking at shortly. I want you to stop the video and complete questions 2, 3, 4b and 5. You'll find 3 is an extended answer. I'm going to give you a little bit of help on that on the next slide. This is question 3, the essay question worth 8 marks. Have a read of this and then go on to the next slide where I'll give you a bit of advice. When we're answering an 8-mark question, we've got to be really careful to make sure we can get to the top band marks and get the best results we can. Now, first of all, it's worth noting that rather than just jumping in, we need to plan and think of the keywords that we're actually going to include. We need to think about how the marks are going to be distributed. This should take you roughly 8 minutes to write. Now, I'm going to show you the mark scheme on the next slide. Now, you should have a copy of this with your exam question, so you can have a look at this and reference this yourself. Now, we want to be going for top marks, a high level response. And if you look at the top of this, you can see mark band, the top mark band with 6 to 8 marks says you need a high level response. You've given a comprehensive response stating most of the bullet points, the ones below in the list, for all 3 points. So it's looking for 3 points really below. And you've used technical language. That's key to get in this band. If you look at the bands below, they've not got all the points and they're not necessarily using technical language. So the points that you'd need to include, and you need to have planned first to think what you might include, are that you've talked about the different registers, the CAR, the MDR, the MAR, the PC and the ACC. You've talked roughly about what the different registers do. Saving, how we save data. So the current instruction register sends addresses to the memory address register and data is sent to the MDR. All data to be saved uses the accumulator. Then there might be other points that you've included as well. So for example, the ACC does all arithmetic and logical operations. You might have mentioned the buses and how they're used to transfer data. The control unit is used for synchronization. So if you look on the right hand side, there's also some information about the examiner's comments. It basically tells you there are some good write-ups, and a lot of people have talked about the ACC and ALU. But the control unit, CU and the IR were not talked about very often. And this is something that you should be talking about in this answer. Your homework should be to create a revision resource for the whole of this topic. That means you need to include information about the buses, you need to include the registers, you need to include all the different components including the ALU, the ACC, the CU, etc. And make sure you bring that in for next lesson. Can you guess the 2 missing words from this definition? The program counter holds the something of the next instruction to be something. Pause the video and see if you can figure those out. So the program counter holds the address of the next instruction to be executed. Can you figure out what the missing words are? Pause the video, try and write them down, and then start playing again and I'll give you the answers. So the CIR, the current instruction register, it holds the current instruction being executed. It's divided into opcodes and operands. The MAR, the memory address register, it holds the address of the memory location from which the data or instructions are to be fetched from. And finally, the MDR. The MDR is a temporary store of data read from or written to memory.